Hey everybody, we're going to do a special video today at the request of our good subscriber 2AG, or Togue, I'm not sure how he pronounces it. And this is going to be about the test equipment that I use when I test a guitar amplifier that I build. How do I know if the signal's clean? How do I know if it's got problems? So I'm going to walk through the equipment that I use for that process today. I'm going to show you how I connect it, and I'm going to show you how to read the results and how to modify it. So, just to walk through the equipment real quickly, we'll start with this box here. This box is a dummy load box. I got this off the YouTube channel of D-Lab, Terry at D-Lab. So basically, what you have here, let's zoom in, is you have a selector switch. Okay? Position 1, right there, indicates that you're connecting to a 4 ohm head. Number 2 suggests that you're connecting to an 8 ohm head. Okay? And there's a selector switch here between a 4 and an 8 ohm right under this cable, if you could see it. All right? So basically what we have inside here are two 4 ohm dummy load resistors, 200 watts, and they look very similar to this one. See how big that is? And the reason why you need something like that is because when you're removing a speaker load from an amplifier, you could burn out a resistor real quick. So you make these things 200 watts, you put it in there, you never run these things very long, you run them for a short period of time. And that's what I have in there. So basically what that switch does, right there, is that will either connect the two 4 ohm resistors together and make them 8 ohms, or isolate it and have just one which is 4 ohms. Okay? There's also a watt meter here. So when you'll see when we connect the amp, it's actually going to display the watts that are being output from the amp. Okay? And it goes all the way from 1 to 100. Most of the amps that I build are in the 5 to 10 range. Then I have an output here for a scope. Okay? And this is basically taking the signal that's going into the dummy load, taking it out and throwing it up on an oscilloscope, which is right here. And that's a Regal DS1102E. Very simple. I have that in channel 1. And then I have an input. Alright? And the input here goes basically to the output of the amplifier. Very simple. The speaker output. Okay? Last piece of equipment that I use is this audio generator. And this is a GW Instech model GAG810, and you'll see it has a frequency range of times 1, times 10, times 100, times 1K, and times 10K. Lets me change the waveform, gives me an amplitude, gives me an attenuator for dB, and there's my outputs right there. 600 ohm output. Now I found for testing amplifiers the best settings are 800 hertz, which is the 80 right here by 10 at 150 millivolts. At 150 millivolts, you'll loosely figure that out when you get the scope up and running. So that's the test gear that I use. Let me get the amplifier that I was showing you yesterday and connect it, and I'll show you that step by step. So I'll be right back. Okay, so before we continue, I have to warn you. This part of the operation is dangerous. When you have this amp turned on, you could have anywhere from 400 to 600 volts of DC running through here. All right, now these caps are rated at 475, so you know it's going to be less than that, but I've done some readings on this thing and I'm up to about 380, 390. I'm not going to show you the voltage ratings on these things. You should be able to figure that out from the schematic. It shows you where you should be able to pick up the voltage ratings here. But just keep in mind, even when doing this test, you have to observe all the safety rules. One hand behind the back, take off your watches and rings. You know what I'm saying? No, never have two hands in there. So let's start to connect this. So first thing we're going to connect to get this going is the output of the amplifier. Now, on this amplifier, it's right here, right there, okay? And I have to tell you, never ever turn on an amplifier without a speaker connected, right? Because if you do, you're going to blow out your output transformer. all that energy has nowhere to go. So you have to have something connected. That's why you've got a dummy load. The reason why it's a dummy load is when that audio generator starts pitching out that squeal, it gets really annoying to listen to it on a speaker. So that's why you put it into a box like this that has no speaker, because you don't want to hear it. So output of the amplifier to the input of the dummy load box. Okay, we have a wire going from the scope output of the dummy load box to the oscilloscope. Let's turn that on. And we'll boot that up. Okay, and then the last step is to connect the audio generator right there to the input. So let's do that now. So basically what I use is just an old wire that's been cut, and I plug that into the normal right there, and on each end I have this alligator clip which goes to the audio generator like so. We're going to separate those, make sure they don't touch. We're going to turn on our audio generator like that. Okay. Next thing we're going to do is we're going to take our amp. We're in channel 1, so we know this is the volume control. We're going to keep our tone all the way down, and we're going to make sure our volume is all the way down. All right, now we're going to plug up the amp, and we're going to turn it on. Okay, we're hot. First thing we're going to do is turn it on. Okay? And as you turn it on, you got to let those tubes heat up. You'll see the oscilloscope still shows nothing, right? This is an 8 ohm amplifier. The output transformer is 8 ohms, and you should be able to figure that out. So therefore, we have this set for 8 ohms, like I showed you earlier, right? All right, so this has had a few moments to bake. So just to check, we have our audio generator on. We have our dummy load connected right there, and we have our scope. So we're going to slowly turn the volume knob right here, and hopefully you'll be able to see the scope react. Just like that. I'm turning it. I think you could see both there. And it goes away. And we turn it up. And we turn it up. And we're up to 6. And we're up to 9. And we know from the video I showed you yesterday, at 11 it's going to start breaking up. And there it is. Right there on 11. Okay? Now what does the breakup mean? On any amplifier, your goal is to get a clean sound, but you always want to have that little bit of a breakup and that grittiness. That's exactly what this is showing you, that this amplifier is breaking up at about the 11 mark. Now you could bias the tubes hotter on an amp that allows you to bias them, and you can cause that breakup to happen sooner, or you can bring the volume all the way down like this, and you can turn your tone all the way up, which is going to allow more of your high frequency to come through when you have your tone up. And then you can bring this up, and we're going to go at 1. I'm going to read off where I am. 3, 4, 5, 6, 7. Right there it starts breaking up at about 8. And then here it totally falls off the rails. Okay? So we're going to bring that back down. Again, you never want to leave these things running a long time, because you are pumping something through the amplifier to those resistors. And although those resistors are big and beefy, you don't want to do that. So I'm going to set the camera down because I want to show you one other thing. So what I'm going to do is I'm going to get the signal going, and I'm going to take this plastic tool and I'm going to tap inside here. So you're going to hear this tapping noise. And what I'm going to be doing is tapping the components after it's on and seeing if I see any deviation in the signal. So let me set the camera down and we'll do that. Okay, so we're going to turn our amplifier up to the, let's say the 9 mark right there. And you'll see that we're running a very, very clean sine wave right here. Not much happening. Now I'm going to start tapping on those components that I showed you. Those are the orange drops. That's good. So everything's nice and clean there. I'm going to tap on the tubes. Rectifier tube, output tube, preamp, preamp. not much movement. I'm going to tap on the wires. The first wires I'm going to tap on are the 5-volt filament, 6-volt filament lines. And then I'm going to tap on some of the wires that connect to the tubes. Some of the resistors. Now this is the first thing you should do if you ever work on an amp that has a problem. You should put it up on this kind of setup and you should tap around. 9 times out of 10, you're going to find your problem. I had an amp that I was working on recently that had one of those ceramic disc caps that was cracked in half, but you couldn't see it. It didn't appear to be cracked. You couldn't tell if you were looking at it. And I used this little tapping tool here and tapped my way around and found that the actual capacitor was broken. And as soon as I hit it, it cracked in half, broke off. That was the source of my noise. So that's what you do with these things. You put the scope up and you're able to see if the signal is solid or if you're able to make it jump around. If you make it jump around, you know you've got a bad solder connection, a bad ground connection, etc., etc., etc. So just to recap, I'm using a GW Instech GAG 810 audio generator right there. I'm using the Regal DS 1102E, and I'm using that homegrown dummy load box. To end this video, I'm going to show you a drawing of the inside of the dummy load box in case you want to build one. So let's go do that and we'll be done. But to be safe, we're going to power this amp off. Okay, we want to be safe. We're going to power this off and we're going to power this off. Safety first. Alright, let me show you the drawing. Be right back. Okay, so here's the drawing. Now, I didn't follow this exact drawing on mine. There's a few things I didn't add on mine, but let's start where we go in. So here's the input of the amp. Okay, this is that orange wire that I showed you going into the dummy load box. And what it's doing is it's going through a 10K resistor and it's going through a capacitor. I'm sorry, that's not a capacitor, that's your plus and minus. It's going through a 10K resistor and going to the switch. This is a selector switch that I showed you, 4 ohms, 8 ohms. Okay? It's coming around here. It's going to the watt meter. This is the watt meter I showed you. It comes back down around here through the switch. And this is where you connect your 2 4-ohm resistors together to get your 4 ohms or your 8 ohms. And this is the switch that says 1, 2, 3, or 4 that I showed you. Now, on this model, there's a speaker built in that you can turn on and off. So if you wanted to hear the squeal, you could turn that speaker on and off. No need for me to do that. I don't need to hear the squeal. But it could be handy if you wanted to know, for example, if your signal generator is working. So you've got 2 switches, one that determines 4 or 8 ohms, and one that is a rotary switch, which shows you where you are measuring. Then you've got your watt meter. Very, very simple drawing. I'll hold it there for a second. This way, if you want to do a print screen, you've got it. Okay. Last thing I'm going to show you is the watt meter on our setup. I didn't do that before. So let's do that and then we'll wrap up the video. Okay, I want you to pay close attention to that watt meter. Now, I'm only going to be pushing out about 1 watt here. I'm not looking to push out 25 watts. That's not the intent. The intent is to make sure you're pushing out power. So I have my scope back on, I have my audio generator back on, I have the amp back on warming up, and I'm going to turn the volume up slowly. And you watch that. So we went all the way from 0 to about half a watt. We're going to go a little higher. And you may be able to hear that. Right there. So we're currently at about half a watt, I'd say. Now you can change the settings on your audio generator to push or pull more. We're not going to do that. I'm lowering the amplitude and you'll see it drops down. If I raise the amplitude, it'll go up. Remember, the more you drive the amp, the hotter those resistors are going to get inside the dummy load box. So you don't want to do this for very long. I have it right now singing. So there's the oscilloscope. You'll see it's completely flat on top. All right. So that's what the watt meter does. If I was working on a more powerful amp, that meter would definitely jump up. So that's where we are. I'm going to lower this down because I don't want to burn out those resistors. And that's it. Okay. Let's wrap it up. Alright, so 2AG, I hope this helps answer your question about the test setup that I use. If it doesn't, just leave me a comment and I'll be happy to answer the question. I hope this helped any of you that are looking to do this kind of work. It's actually a really good setup for determining if the amp is healthy or not. And remember, always use safety. Okay? Hope this helps. If you have any questions, let me know. This is Ron.